Okay, let's get started. Okay, so Miss O'Brien went through U substitution with you guys, I think. Or I know she made worksheets because I was copying those worksheets. Now, the question is, how are you guys with regular integrals? Like, the integral, for instance, of x squared dx. How is that? Well, we use what we call power rule. So I would say call out the rule that you're using. So power rule messes with the exponent. And this would be plus 1 over 2 plus 1. So a lot of these integrals are pretty easy. And if I take the derivative of this going forward, d over dx of x cubed over 3 plus c, this will also be power rule going forward. We bring the exponent to the front, and we subtract by 1. It looks a little better. So this would become 3x squared over 3, and then the derivative of a constant is 0, and that becomes x squared. So to get started about this, we take derivatives, we take integrals, so the back and forth, we go back and forth with them. Now, if you know your basic derivatives, that means you should know your integrals. We're just trying to figure out a way backwards. But going backwards often is harder. Sorry about that. It's harder when we have something called chain rule. And remember chain rule, so these are easy problems. But if I give you a derivative of sine of 2x squared, well, when I take the derivative of sine of 2x squared, we need chain rule. We do take the derivative of the outside first, which is derivative of sine is cosine. Leave the inside alone, which is 2x squared. Then we multiply this by, I don't like that. We multiply this by the derivative of 2x squared, which is 4x. So we write this as 4x cosine of 2x squared. Now, if we want to go backwards, the integral of 4x cosine of 2x squared, how in the world were you supposed to know this was just sine 2x squared? If you look at your identity sheet of all your integrals, you are not given any integrals with a bunch of stuff in the front. You don't see stuff like this here randomly, or stuff that's in here that's not nice, like for instance a value of x. What you're given in your integral sheet is a set of rules, basic rules. You have the integral of cosine of u du is equal to sine of x. So sine of, not x, sine of u. That's what you're given. Now, how am I supposed to use that rule, for something like this here? Do they look alike? Do they look alike to you? Come on. They don't look like it at all to me. So here's what U substitution does. U substitution simplifies everything. I'm not kidding, it simplifies everything. The goal of U substitution is to simplify everything that we're doing. So let's go ahead and do this problem. The integral of 4x cosine of 2x squared dx. Does that look like our rule, the integral of cosine of u du equals to sine of u. Does it look like it at all? I'm going to say no. Doesn't look like it at all. So here's what we do. We cheat. We save this here. I'm just going to call it u. Integral of 4x cosine of u dx. Now the problem is, look here. The rule says that dx has to be a du. So how are we going to make that dx into a du? Well, what does dx refer to? What does dx refer to? Dx is just the derivative of x. That's the basic idea, you can say that. So let's try to get the derivative of x. Well, we know u is equal to 2x squared. Didn't we say that's our u sub? See, this is why we call it u sub. U is now 2x squared. See, we made it easier. Looks a lot like this problem here. And how can I get the derivative of x? We just take the derivative. Take the derivative to both sides. The derivative of u is just du. The derivative of 2x squared, you need power rule, is 4x. And the derivative of x is dx. Again, real quick, just the derivative of u is du. Derivative of x is dx. Okay, here's our part now. We need to somehow, we said we're trying to get this guy here, dx, right? We're going to get dx right here, solve for dx, by getting rid of the 4x. So opposite multiplies divide 4x to both sides. If you notice something kind of cool, I'm going to rewrite this now. The integral of 4x cosine of u du over 4x. What divides out? The integral of rewriting it 4x over 4x cosine of u du. And remember our problem back here? Isn't that what our goal was to get? This divides out, and we're left with the integral cosine u du, which we said was sine of u. We're going to go ahead and say, hey, well, we didn't start off with u. Didn't we start off over here? Didn't we start off over here with 2x squared? Well, that's our u. Let's go ahead and plug that u back in. So equals to sine, oh sorry, I need a plus c here. Sine of 2x squared plus c, which is back to our original problem. How we started way up here. Okay. So let's just go over the purpose of U-substitution. The purpose of U-substitution is taking something that does not look like an identity I already know. It doesn't look like an identity I already know. If we can get rid of that inside value and call it something nice and simple, let's call it something nice and simple. Hey, then we can make it look like an identity that we know. Okay, so we'll do a couple examples of U-substitution in general, and then we'll see how to identify problems that are U-substitution. Okay, here we go. The integral of, let's do something like, we'll use another, oh yeah, here we'll do this. 2x 1 plus x squared to the 4th power plus, dx. Now, that problem looks a little trashy. It looks pretty messy. Like, how am I supposed to do this? It doesn't look like any identity problem that we know. But what if I told you this problem here was really the integral of u to the 4th du? If I told you it was actually this problem here, u to the 4th du. What if I told you this problem? Because couldn't we take the integral of this guy pretty easily? Wasn't it just power rule? U to the 5 over 5 plus c? Or power rule? Plus 1, 4 plus 1. That's how we end up with 5 over 5. Okay. Now, what part of it do you not like? Well, you can say I don't like the whole problem. But for me, I'm going to say, know what? I don't like this whole section here. So I'm going to call that u. And I'll teach you a little bit how to figure out which one's u. U is equal to 1 plus x squared. Well, if I call that u, it'll be the integral of 2x u to the 4th power, which is nice, dx. But do we really want dx? Do we really want dx? No, we don't. We want to switch that to du. So instead, we're going to say, hey, I can make this my dx, and I can plug my du here. So the derivative du is equal to, what's the derivative of, let me write this a little nice for you guys. The derivative of u and the derivative of 1 plus x squared. The derivative of u is just du, leave it alone. The derivative of 1 is 0. The derivative of x squared, you should write that, it looks ugly if you do that, is 2x, and the derivative of x using chain rule. Let me explain that out a little bit more. If I say d derivative of x squared, can we touch the x inside first? No, we have to deal with the outside. So that's where we deal with the chain rule. This is actually a chain rule problem. This becomes, the exponent goes to the front, so it's 2x, leave the x alone. That's my first step, just deal with the outside. And then chain rule says, hey, what's the derivative of the inside? What's the derivative of x? That's dx. Okay, now that we know what we can solve for what dx is. So du over 2x by dividing the 2x to both sides. Hey, now we can substitute dx. That now becomes du over 2x. du over 2x. And turns out, if you see this something pretty here, look what happens to this 2x and this 2x. They cancel out. We're in an integral of u to the 4th du, which is what I was claiming. And then we can take the integral of that. Now that's back to something that's easy, something that we've seen before. So now I take the integral like we did before. So this is equal to power rule plus 1, let me write that with a different color, plus 1 over 4 plus 1, right? And that becomes u to the 5 over 5 plus c. And we said that's what was going to happen before. And then we're going to resubstitute back in what was my u, because that's not my original answer. So my original u value was 1 plus x squared to the 5th power. I'm going to write 1/5 in the front to make it a little prettier, plus c. And that is our U-Substitution problem. You guys have any questions about how we can do this? Not yet. Okay. Well, let's use another integral that you guys should have learned. You guys should have learned this integral. The integral of 1 over x dx is equal to ln absolute value of x. Okay, let's see. We're going to use that one. So if I give you guys a problem, the integral of, let's use 2x, like we did before, over 1 plus x squared dx. Does this look like this identity? It doesn't, right? Well, what if I call this here u is equal to 1 plus x squared? In your head, can you take the derivative of this quickly? What's the derivative of 1? 1. What's the derivative of x squared? Bring the power down, power rule. It'll be 2x. du is equal to 2x dx. Now, if you look at this 2x here, does that 2x look like it's going to cancel with this 2x? Yeah, perhaps. Let's go ahead and move it over. It will be du over 2x is equal, 2x is equal to dx. Now we have all the parts. We have our dx player. Whoops. Dx, and that's going to take over this guy. We have our u, that's going to take over this guy. And we see that the 2x, so let's go ahead and rewrite it. The integral of 2x over 1 plus x squared becomes a u. And then dx became a du over 2x. See, that's my dx. And then this guy here is my u. Hey, and look what cancels out. What divides out? What divides out? Sorry, I repeat myself a lot. The integral of 1 over u du, which we said was our identity, natural log of u, plus c, don't write the plus c, did I write plus c up here? I did. This equals to natural log. We're going to copy back our u value, which is 1 plus x squared plus c. Now, we have one more step here, just an algebra 2 step real quick. Do I really need the absolute values? According to that identity, yes, we do. But 1 plus x squared, will this ever be negative? It'll never be negative, so we don't need our absolute value. 1 plus x squared. C, and that is our answer. The goal of being able to use U-Substitution is to know your basic integrals. And then identifying which values will cancel out. Now let's look at this worksheet over here. And there's a lot of examples here. Look at this guy here. Can you take the derivative of 1 minus x squared? You end up with a 2x, and that 2x, the x will divide out with the x on top. Look over here. X squared plus x squared minus 1. What's the derivative of x squared minus 1? It's 2x, and that x will divide out with this x on the outside. Look at this exponent here. Sine of x. What's the derivative of sine of x? The derivative of sine of x is cosine. That gets rid of this cosine right here. Look here, x squared. What's the derivative of x squared? 2x. The x divides out with this x here. Looking here, what's the derivative of x cubed? 3x squared. and then derivative of 1 is 0. So we're left with a 2x squared, which cancels out with this guy. Looking here at the x cubed. What's the derivative? Sorry, x cubed plus 1. That's just going to be 3x squared. And this x squared divides out with this x squared. What happens over here? The derivative of 1 minus x squared. This is negative 2x. And this x gets rid of this x. What's the derivative of e up here? What's the derivative of e to the x? E to the x. Oops. E to the x. And that e to the x divides out with this e to the x. So all these U-substitution problems, they turn out to be kind of easy because you can see what would divide out. We can do it for the rest of these problems. If I look over here at number 11, x squared, what's the derivative of x squared? 2x, and this 2x divides out with this x. How about this guy? Darn it. What about this guy here? 1 minus x squared. That's a negative 2x. And this negative 2x divides out with this x. The negative 2 stays about the x. Looking over here, x squared. What's the derivative of x squared? 2x. Doesn't this x divide out with this x? 1 minus x squared. The derivative of 1 minus x squared is 2x. 0 plus 2x. And that x divides out with this x. So that's the idea of U-substitution. So let me do some more integral problems for you guys that you might need help with. Okay, let's get started over here. I can provide this worksheet if you guys would like. I'll put it on your, it's called the Schoology link. Okay, let's do problem number 2. The integral of 1 minus x to the 9th power dx. Do you really want to multiply 1 minus x 9 times? Nope. So we'll call it u. Let's see what happens. If I call this u, it'll be u to the 9th. Integral. I'm not gonna write the dx right away. I'm gonna just write on the side. U is equal to 1 minus x du is equal to 0 minus 1 dx. Or du is equal to negative dx. So try to get dx alone. Dx is equal to negative du. And that's what we're going to write here. Negative. All right, change the color so you guys can see it a little better. All right, this is a negative du. This is the integral of negative u to the 9th power du. Since negative is a constant, we're going to move it to the front. Negative u to the 9th du. And this is the power problem. Plus 1. 9 plus 1. Negative u to the negative u to the 10 over 10 plus c. Our u value is replaced by negative 1 minus x to the 10th power. Sorry. 10 power over 10. I could write that as a 1 over 10 in the front also. And that's the answer right here, number 2. Go back and do the same problem yourself. Let's do number 3. The integral of dx over 1 minus 4 minus x squared. Well, this is going to be this is going to be right. U is equal to 1 minus x. Du is equal to 1. Derivative of 1 is 0. And the derivative of x is negative 1 dx. Du is equal to negative dx. Dx is equal to negative du, because I moved the negative over. Let's rewrite everything. The integral of negative du, because dx here was negative du, over u squared. The negative goes on the outside. Now, when you're looking at integrals with stuff on the denominator, could I write this on top? Could I really write this on top? How can I write things on the denominator and the numerator? How can I change that exponent? U to the negative 2 power. And then now this is a power rule problem. So our power rule is we go ahead and we add n plus 1. We have 2 plus 1. That's our power rule. So we're left with negative u to the negative 1 power over negative 1 plus c. Rewriting, the negatives cancel out. 1 over u plus c. And we know what u is. 1 over 1 minus x plus c. Check our answer for number 3. Oops. That was a 4, I'm sorry. That was a 4. Any questions? Let's do the square root number 10 here. Number 10. The integral of x square root of x squared minus 1 dx. I'm going to use U sub. U is equal to x squared minus 1. Automatically, once you're at the u, go ahead and take the derivative. Du is equal to 2x dx. Again, the reason why the derivative of x squared minus 1 is the derivative of x squared minus the derivative of 1. This goes to 0. The derivative of x squared is power rule first, 2x, and then the derivative of x is dx. And that's how we end up with this value here. We're trying to get rid of our dx by substituting for du, but du has a cost. It's going to be divided by 2x. Let's rewrite it. The integral of x square root, and we said this was going to be one big U, and then this was going, dx over here was going to become du over 2x. And you notice that my x is divided, so we have no more other variables. Look at this problem again. Do we have any other variables besides u? We need to be all speaking the same language here. We need to be. Integral, if not, it's not going to work. Square root of u du. And this 2 here, that 2 there, that 2 here, right? We're going to write that as a 1/2 in the front because that's on the denominator. Now, this problem might be tough, but we don't have any identities for this. But you could write this as a exponent instead. 1 over 2 integral of u to the 1/2 power. Remember, square roots can be written as exponents. And now it's a power rule problem. Plus 1, 1/2 plus 1. So 1/2 u to the 3 over 2, because 1/2 plus 1, common denominator, will be 1 over 2 plus 2 over 2, 3 over 2, over 3 over 2. We don't like our fractions, so multiply by the reciprocal. 1 over 2, 3 over 2, sorry, other way around. 2 over 3 times u to the 3 over 2 plus c. Those divide out. We're left with 1 over 3. And we rewrite this as a radical. Let me see, what do they do? Do they want a radical? Yeah, they want a radical. This is our square root. And this is our cube. And we're just going to copy u into it. And we said the u value from up here was x squared minus 1. Wait, was x squared minus 1? Yeah, x squared minus 1. And that's our answer. Oh, I lost a negative. Whoops. Wait, did I lose a negative? No, I didn't. We're good. Okay. I'll put up a list of problems so you guys can practice. If you guys have any questions on any of the problems, let me know. You really have to practice U-Substitution. U-Substitution is one of our major ways of taking integrals. Okay. Let me know if you need any more help.